Hi, David.
Скажи, пожалуйста, ты часто вообще выступаешь?
Do you present often with presentations on IT conferences?
I do a few, yes. I was doing a talk remotely in Sydney last week, and then in Adelaide last week. I was in London at the start of the year, so I try to do a few every year to keep things interesting.
Скажи, как тебе формат онлайн-выступлений по сравнению с очными?
So, what do you think about the online format compared with the in-person presentations?
So it's nice to be able to speak at various conferences around the world without moving, but I definitely miss the audience interaction and seeing people nod along and giving that instant feedback. So it's a little bit different, but it's a good opportunity to be able to do this and without being too jet lagged as well.
Отлично. Итак, давай тогда перейдем к твоему
Great, so
докладу без
let's
jet
then
lag.
switch to your presentation without any jet lag. You have the floor.
Hello, thank you for attending this talk. Thanks for coming. My name's Dave, and I'm going to talk to you today about source generators, specifically about C#9 source generators, which is some new features coming to C#9. But first, let's just talk quickly about what is a source generator. So source generators have been around for a while. There's lots of different options, different ways to generate source, and we'll talk about a few in a minute. But in general, in case you don't know, the basic practice is all around automation. It's about writing code that writes code. So very often as programmers, we have to write a bunch of code that's really repetitive or that's really boring to write. So you might be writing, let's say you're writing a class that has to access, it's going to represent some data in a database table. And so you've got to write all the properties that match all the column names of the database. And then you've got to write the code that fills in those properties when you read from the database, or fills in the database when you write to the code, etc. That's why we have things like Entity Framework. And part of what Entity Framework does is it generates a bunch of code and it can save you from writing it manually. So source generation itself is very common. What's new though is the specific C#9 option that's available. So this is a very high level view, obviously, of what goes on when you write code. You have your C# files, they go into the C# compiler, and at the other end comes the DLL. And so code generation, in general, can fit into this process in a number of spots. There's a bunch of options, MS Build, CodeSmith, these are just two examples, there's many, but there's a bunch of options that run before the compiler. And so what this means is essentially writing some C# files that live next to your existing C# files as though you wrote them, and then doing that before the compiler sees them. So to the compiler, there's no difference between this generated code and your handwritten code. It doesn't know the difference. There's also the option of doing code generation after the compilation. This is where tools like Fody or PostSharp might be used. And again, there's many more, but these are two of them you might have heard of. And because these come after the compiler, these work on the IL, excuse me, on the intermediate language, which is what is in your DLL. That means they're a lot more powerful in general because they can change anything. You can use them, in fact, to change parts of the .NET runtime or libraries you might not have the source code to. So they're super powerful, but because they work on IL at that level, they're also a little bit more complicated just by their nature. So in C#9, there's a new feature called source generators, which works inside the compiler. And so before we talk about how it specifically works, let's talk a little bit about what happens inside the compiler when you compile your code. So the first thing that happened, the compiler is built up of phases, and the first phase is called the parse phase. And this is where your C# files are taken in and they're parsed to produce a syntax tree, an AST, abstract syntax tree. this contains information about what your code represents in terms of methods and fields and properties. And it contains the names of types that you refer to, but it doesn't have a lot of rich information yet. So from the parse phase, we then move into the compile phase. And this is where your syntax trees are sent along and they become a compilation. A compilation now has all of that rich information about types. So this is where, excuse me, if you were to define a string, for example, if you use a lowercase s string, then the parse phase knows that's a keyword, that's the string keyword. And that has some meaning in C#. If you were to use a string with an uppercase s though, that's a type from .NET. So the parse phase doesn't know anything about it. It knows it's a type because of where in the file it is. It knows it's called string, but that's all it knows. The compile phase is where that information is pulled up, say, right, well, what might this string be? And it goes through all your using statements to work out, okay, well, this could be system.string. It goes through all your references to find all these types. So the compilation is super rich. And then after the compile phase, we go to the emit phase, and your compilation becomes IL. And this is where we produce the DLL and everything. Excuse me, the rest is history, as they say. So source generators are a new thing that lets you hook into this process. And the way that they work is as follows. So we have our source generator off to the side. Now this will be something that you would define potentially as a project in your solution, although probably more likely you would deploy it via NuGet and reference it as a NuGet package, either internally or publicly, that's up to you. But usually the source generator is created and sort of, it's not constantly worked on along with your code, but it certainly can be initially. So what happens is your C# files come in through the parse phase, they produce an abstract syntax tree, that's the same. The syntax tree gets pushed over to the compile phase, we produce a compilation. But now what happens is your source generator is called. Your source generator is given the abstract syntax tree and the compilation, and it produces some new source. It produces a string, or multiple strings, but it produces some new code. That new code, that string, is sent back through the parse phase, becomes a syntax tree. Whoops, went to one too far. Sent into the compile phase and becomes a compilation. And then the compilation from your project and all of the source generators you might have are combined together. And then we go through the emit phase and out to your DLL. So it's really about adding in more code, but controlled by your source generator. So your code that you write in your source generator writes more code. So this usually at this point raises a bunch of questions everyone has, so I'll try to predict what they are. The first question everyone asks is, so does this create new C# files on disk? And at the moment it doesn't, but potentially it will be an option in the future. This is operating inside the compiler. So all of this source code is generated inside the compiler in memory, and then the compilation is generated in memory. This means that it's hyper responsive. Literally every key press you press in Visual Studio as you're coding could be creating new compilations and generating more source. So one of its strengths, that's one of its strengths, because the traditional options, you write all of your code, you save all your files, they operate on files or they operate on the IL. You have to have sort of everything in place. Source generators, because they're called inside the compiler pipeline, they can be super responsive. Can you have multiple? You absolutely can have multiple, but they cannot depend on each other. The order in which source generators run is not determined, and so you cannot have a source generator and then have another source generator that uses the output of that. It won't work. Is there a better way than producing strings? There is, to some degree, and it's certainly when you start writing source generators, it always feels weird to have to write these strings. You're working within the compiler. You can see all of the source code that is in the project because you get those syntax trees. So you're working with these syntax trees, which is this sort of high-level construct of C#, but you have to produce strings. It seems really backwards. But the fact is, the compiler is really good at taking a string and converting it into C#. That's into a syntax tree. That's what it does all day, every day. It's really fast and it's bulletproof, basically. If you were to be able to give the compiler the pre-made syntax trees, it would be trivial to break it. Essentially, you can construct syntax trees that aren't valid C# really easily. The best and most efficient storage for C# code, turns out, is C# code. That's kind of why the language was designed that way. So yeah, we just produce strings. If you really want to, you can use some high-level concepts and then convert to a string at the end. I'm sure there will be libraries and ecosystems that are built up to help produce these things over time, but strings is the sort of best common language, if you like, to talk. And then can they change code? And this is the biggest sort of, gotcha. If you've used especially something like Fody or PostSharp, but even any of the existing MS Build, CodeSmith systems, all of those existing systems, they work on your C# files or your IL, and they can modify whatever they want because it all happens before the compiler ever sees anything, or after the compiler is finished, in fact. Because source generators work inside the compile process, though, the compilation of the project has already been produced and it's immutable. Everything inside the compiler is immutable. So you can't change the compilation of the project. You can only add new things onto it and then they're combined together. There are some tricks that I'll show you for how you can sort of do similar things to changing code, but you can't actually change code. And this does limit what you can do with source generators versus those other tools. But at the same time, it allows it to be a really sort of simple solution from the compiler point of view, which is basically the reason we have it. To produce something that was full-featured and did let you modify code is, not impossible, but certainly orders of magnitude more complex. And there's been lots of attempts over the years. This is coming after, about 5 years after it was first talked about. And the only reason it's coming is because it's a little bit simple. And then the IDE experience in Visual Studio, it's definitely going to get better. It is not the best at the moment. Potentially by the time you're seeing this talk, it will be better. I've seen some internal previews of things and it's definitely on its way. So what are some things that source generators can do? So firstly, they can access additional files from your project. So the source generator runs inside the compiler, which deals with C#, but because it's called by MS Build, it knows a bunch of things from MS Build. And so one of those is additional files. So this is sort of opening up an area of source generators where you might want to build strongly typed wrappers for things. So you could imagine you had an XML file to define all of your settings, and you want to generate a class that gives you access to those settings without having to read the XML. And if you use a source generator to do this, you save yourself the work of every time you add a setting to the XML, do you have to add a new property, add a new line to the read method, add a new line to the write method, etc. With this, you can write some code that can take in that XML, because it's part of the project, it gets to read it, take in that XML, and then generate the class on the fly. So additional files is really powerful for a specific type of source generator. That link at the bottom there is to a very interesting project by a friend of mine, Scott, who wrote essentially a compiler for another language inside a C# project. So you create the source code in the other language as additional files. The source generator runs and produces C# files, C# code. There's no other C# code in the project though, so it's sort of enabling a whole DSL essentially, which is really interesting. Source generators can produce diagnostics, which is really helpful as far as validation goes. And I'll show you one example later, which is really powerful. But essentially, again, because you're inside the compiler, if the compiler can create a diagnostic, well, so can you. So your source generator can report errors or misconfigurations. So for example, that settings XML, maybe it's badly formed XML, that can actually fail your build by giving these errors. They'll show up in Visual Studio, they'll show up in the output log, etc. You can fail your build when the state of things that you want to generate based on is not valid, which is much more effective than failing it at runtime when you've got to read that XML file. The note here is don't try to write analyzers as source generators because analyzers already exist. We already have good support for these sorts of features, and if you just want to validate and you just want to raise errors, use an analyzer and you'll have a better experience. So I talked a bit about how there's some ability to change code, and really what it comes down to is allowing you to extend existing code. And the method for doing that is partial methods. So partial methods have been in C# for a while, but there's some changes in C#9. So before C#9, a partial method used to just be, like that example there, partial void method. It couldn't have returns, it couldn't have output parameters, and it couldn't have access modifiers. And the way the compiler worked was a partial method was essentially saying, hey, someone might call this method and someone might implement this method, but we don't know yet. And if at compile time no one ended up implementing that method, then the call sites went away, the method definition went away, it was though it never existed. What's now happening with C#9 is you can put output parameters and return types and modifiers on things so they get a lot more useful. Now, obviously, if you've got a return type, or if you're returning something, if you've got an output parameter, you can't have that code just disappear, right? Because what happens with the return value? If you're assigning it to a variable, well, what happens to that variable? So with C#9, it's extended by allowing all of these new features, but if you have them, you have to implement this partial methods. This is where source generators come in. You can define in your code a series of partial methods and call them at the right points. And this is essentially putting in an entry point for your source generator. Your source generator then generates the implementation of that partial method. And so that is called at whatever point you want. So for example, you could have some common set of code you want to run all the time in every property setter that is generated based on some input. Inside the property setter, you call your partial method, you define the signature of your partial method in the file so that everything knows what it looks like, but then in your generated source, you generate the rest, the implementation of the partial method. So this is a way to not edit the existing code, but allow the existing code to sort of call into the source generator, or perhaps the other way around, allow the source generator to fill in parts of the existing code. So to define a source generator, it's really easy. You reference it exactly the same way as you would reference an analyzer. So if you've got a direct DLL reference, it would be analyzer include equals bar.dll. If you've got a NuGet package, then NuGet handles that for you, but essentially that's what NuGet is doing. With a project reference like this here, there's a couple little tricks you do. So firstly, obviously the normal project reference, you say reference output assembly equals false, which means you don't actually reference the source generator. It's not a dependency of your project. It's just something you want associated with your project. And then the other thing you do is instead of the output type, which normally would be reference, you say, hey, make this an analyzer. And then essentially what happens is the project is compiled and the result is that it looks a lot like this to MS Build, where it says, hey, I've got an analyzer. The project for the source generator itself is really easy. It's a net standard project, so that's easy, works cross-platform, no worries. And you just reference a couple of NuGet packages that define the API structure, excuse me, and everything works as you'd expect. And then the source generator itself, the class, there's a couple of things. Firstly, you tag it with a generator attribute. This is so the compiler can discover it. And then you implement iSourceGenerator. Now, the syntax here, these two classes have changed names recently. That will roll out before release of .NET 5. So depending on when those bits are released and what version of preview bits you're using, maybe take note of that. It's not source generator context anymore, but the same basic idea. A source generator is given two methods. One is initialize, which obviously called once on startup, and one is execute, which is essentially generate the source. Some reasons you might want to do this is there's basically two styles of source generator when it comes to looking at the code in the project. One is by registering something that is going to get called all the time when individual types of code is added, and the other is just executing over the entire project whenever is necessary. And so that's what initialize is for, hooking up that former kind. So the biggest benefit to source generators over any other option is that you're inside the Roslyn compiler, you have access to the Roslyn API, and so you can read all of the code that is in the project. So some tricks for how to do that. Number one, the syntax visualizer. If you install this into Visual Studio, it's part of the .NET Compiler SDK in the standard Visual Studio setup, but it's an optional component. This will show you the structure of any source code you're looking at. That's it on the right there. You can see at the top, we have all the different types of syntax. Down the bottom, we have some properties, etc. If you don't have Visual Studio, you don't want to use Visual Studio, SharpLab has the same feature, a little bit more simplistic, but basically you put some code on the left and it shows you the syntax tree on the right. This is really cool for working out how Roslyn represents code. So if you're writing some code that's going to go through and find all of the methods, well, you can see down here we have a method declaration. Okay, I know I want to look for method declarations. How do I go from there from the parameters? Well, I can see here there's a parameter list. Same thing over here, method declaration, there's a parameter list. So inspecting the syntax via these tools is really powerful. And then really honestly the easiest thing, and the one that I do the most, is just trial and error. I put a breakpoint in my source generator and I press Shift F9 to get to quick view in Visual Studio, and I just kind of drill in. All of the syntax tree, I mean, it's a tree, right? So you can get from any node basically to any other node. You can just sort of drill in. And I find that's easiest to just do in the debugger. So for me, I sort of, like, I'll know what I'm looking for. So for example, if I was looking for this main method, well, I know I'm looking for main method. Maybe I want to pull out the arguments. Well, I'd find the main method, I'd press Shift F9, go look through the debugger, and I basically just look and drill into things until I found the word args. I'm like, that's what I want. So getting used to that Roslyn API and reading up some of the existing docs on how to use the Roslyn API, very powerful. So the other thing you can get to is symbols. Now, symbols has all of your type information. So syntax is just your code, symbols have your type information. And so there's a few tricks with that one. Every compilation has something called a global namespace, which contains everything in the entire worldview of this compilation. That is every type in every reference DLL, everything that contains the whole .NET framework. So if you want to go looking for things, you might want to be looking for IEnumerables or something like that. You can go look in global namespace, find the real type of, hey, what is an IEnumerable, and then go looking for it. Get type by metadata name is a shortcut to that. So if you know the full type name of what you're looking for, pass it into get type by metadata name. That's going to be your good starting point. Get semantic model is a general way to say, give me the symbols for this syntax. So if you've got some sort of syntax you're analyzing, if you want to know the type information from that, you say get semantic model, and then that gives you the symbol information for whatever you're looking at. And then from the semantic model, you call get symbol info or get declared symbol info or etc. Again, the Roslyn API is well documented, but it can be a little challenging. So I usually just use trial and error. There are tools in Syntax Visualizer that seem like they should work, but in my experience, they're just not very helpful. Excuse me. So what you then want to do with your source generator, is you want to generate some new code. And so there's a excuse me. There's a class in Roslyn called a syntax factory. And a syntax factory has the ability to generate code in any language that Roslyn supports, which is only C# and VB, but. And of course, syntax source generators are only a C# feature, so you're really only ever generating C#, at least at the moment. But so syntax factory is highly structured. I don't even know if you can see the code on the left. It's so detailed that I couldn't fit it on the slide, so it has to be small. But essentially, you create a method, and then from there you create the modifiers on the method and the parameters on the method and the name of the method. And it's all very, very detailed. There is a website there called roslynquota.azurewebsites.net, which I can show in a minute if there's time. And it definitely helps producing syntax. The problem with syntax, and why I would personally avoid it, and I just generate strings. So at the end of this little bit of code on the left here, I have this call to a .normalize whitespace. And so this code on the left produces this code on the right. If I remove the normalize whitespace call, then this code on the left actually produces this code. And That's not valid C#. And this is what I was saying before about how it's easy to produce syntax trees that are invalid. When you're using something like Syntax Factory, you have to be very specific and you have to fill in every detail. There's not a lot of help you get. I mean, there's some, like that normalized whitespace method. But so this is where you need to be really careful. Roslyn Quota does, fortunately, help you a lot, but something to keep in mind if you want to go down that path. And then finally, the sort of the trickiest part is how do you actually write them and debug them? Debugging is tricky. It's easy to put in a debugger.launch statement in the middle of your source generator, and that'll, start up it'll give you a window popping up asking you what instance of Visual Studio you want to use. There is a thing called the generator driver, which can be used from unit tests or from test console apps to drive this infrastructure, and that's what I recommend. I use a console app usually, and I run the generator, and then I just output the code, and then I have a look at it and I see if it's right. And then once I've got it to a certain point, maybe I'll start writing some tests. I have there a link to a repository of mine called Source Generator Template, and that includes a sample source generator, a sample project, a sample unit test app, and a sample console app that tests these things. And I just personally use that. Basically, whenever I start a new one, I just copy that, and that's my boilerplate. And then the other thing I've got a link there to is sourcegen.dev, which is a tool I wrote to help me debug them. And that is what I will use now to demo some things. So let's jump over, not to that. So this was SharpLab, just quickly. So this is viewing the syntax trees. You can see I can highlight some code on the left. It'll take me to that syntax tree on the right. Same thing if I click on the right, it highlights code on the left. SharpLab's an amazing website. This is Roslyn Quota. So you type in some code, press this button, and it generates a bunch of stuff. You can even download link pad files. As you can see, you can sort of keep, if you want white space and everything, it starts to generate a lot of code. So be wary of syntax generation. And then this is sourcegen.dev. So this is a tool that I've written to play with source generators. And I think this is the easiest way to sort of demonstrate how they work. What happens here is, this is my program. My program will be compiled. That is sent along. This is my source generator. So my program will be compiled and passed to my source generator. The source generator will run. It will generate this code, which is the generated output. And then this combines with this to produce the output of the program. And so we can use this to start to play around with our source generator. So this is a very simple DI system. What's happening here is I'm saying, hey, find me an ifoo, and the source generator goes through, and here's my little classes here, and it goes and it finds anything that implements ifoo. So it finds this foo here, and it'll return it. Now, let me just comment out some lines here so we can see what's happening. So as I type, this is regenerating my code. So I've asked for a foo, the source generator runs, and here we have the code generated. And you can see when I call getService, it returns to me this object. This object is a foo. So it's found that class that implements that interface, and it's giving it back to me. If I add a constructor to this class, let me just turn off auto refresh because it's a little slow sometimes. If I add a constructor to this class that, say, takes in an iBar, and I refresh, now the source generator is creating a bar, then creating a foo, passing in the bar, and returning it. Okay, so this is very simple DI, but it shows you what can happen here with source generators. So you'll notice this getService, it's a generic method. It says getService of T, it should support anything, but it only ever returns a foo. So why is that? Well, that's because the source generator gets to look at my source code, and it can see I'm only ever calling getService and asking for an ifoo. If I ask for another ifoo, and let me turn on auto refresh now, it doesn't change at all because it doesn't need to. If I only ever ask for ifoo, this will always work. If I make this a transient interface, well, now every time I call ifoo, I want a new instance of foo. And so that's exactly what's happening here. And interestingly, this is actually, I guess, a bug, because this has made bar transient as well, which Maybe it shouldn't have, but anyway, this is only to demonstrate source generators, not demonstrate DI systems. But yeah, because this can actually see the code that is running, it gets to generate really efficient code. Let me just comment that out again, and we'll ask for something else. So now I'm asking for an ifoo and an ibar. Now we need an if statement. So because the source generator gets to look at the code, it gets to generate really efficient code. It gets to do some really clever stuff. And you kind of have to be in this sort of a different mindset. You're running inside the compiler. You can access things essentially. So when you're running a library, if you're running a DI library, you sort of have to sit down and you have to think about all of the things that people might want to do with your code. And you do still have to do that when you're writing a source generator. But the difference is that when it actually runs, it's not guessing. It's not about what people might do. You can see exactly what they do. And so here, for example, we now have an if statement that checks if you want an ifoo. If you don't, it gives you a bar. Right? It doesn't need to check an if type of t equals I bar because it knows there's only two possibilities. The other thing it does now is it generates lazies, because now that I'm asking for two different types, right, I don't want to have the bar instance, this lazy, initialized when I ask for the foo, because that would be inefficient. So it only initializes it when necessary. Again, that's just a feature of this source gen. I can actually turn that off by just typing in false there. This tool will then rerun the source generator, and so, you know, just to simplify things. But so you get to react to the code. The other thing that you can also, just to point out, is I've put some smarts in here about generating these variable names correctly, but you know, that's completely optional. Source generated code, the actual output, can be as ugly as you like. I think it's good to embrace that ugliness a little bit, because it just has to run, and it has to be, well, it's good to be efficient, obviously. Sometimes efficient code can be a little ugly, and I personally think that you're better off going for efficiency in a source generator and not worrying about what it looks like, because at the end of the day, at runtime, that's what's going to matter. And then the final thing to demo, just quickly, if I ask for an ibaz, there is no implementation of ibaz, and so this is where my generator can raise a diagnostic. And this is super powerful, because here, normally with a normal DI system, at runtime, the container would validate that it's got everything and it would throw an exception. So at runtime startup of your app, you're going to get an exception thrown and you've got to deal with that. This breaks at compile time on your CI system or even on your machine. So you know you've done, oh, I've spelt this wrong, or I've forgotten to check in a file, or whatever it is. Really powerful stuff. Do check out sourcegen.dev though to have a play though. There's a couple of other examples here, things like auto notify. This is a good one where it's tagging fields and generating properties, and you can see things like this amount field. It's telling the system to generate a property called count. And so if you scroll down here, we can see this count property and it returns this .amount. This is a super good example of how source generators can avoid using reflection code. There's no code at runtime that has to look up this attribute. It happens at compile time by inspecting the code. So it's really powerful. And this is essentially the unique selling point of C#9 source generators, because they're the only tool that is running inside the compiler, can get access to all this information, and you can write much more efficient generated code. And with that, thank you for your time. If you have any questions, please do let me know.
David, спасибо за доклад, было очень...
Thank you, David. Thank you indeed for the presentation. It was really interesting, and as we wait for the questions from our viewers on the 8800-707-0260 or from the webcast site, I have a question to ask. On one of the sites you said that you had a link to an example of how a ready generator was transforming the code from one language into some other language, into a C# language. Can we use something like that in runtime on a production application?
You certainly could. So this project that I linked to was just a fun project a friend of mine put together. But yes, you could use it. What it essentially does is it transpiles the code from the source language into C#. So what gets produced is a DLL that contains the C# code that you would have had to write that program in C#. It's just that you wrote it in a different language. But so at runtime, it's just a C# program, same as any other. That input file that is the original language doesn't need to be deployed. It's not required at all. Everything so the result of it is baked into the DLL.
Mm-hmm. Здорово, спасибо.
Wow, that's cool. Thank you. Thanks indeed. You said that it's better to generate a C# code in source generators using strings. How do you think, will it somehow affect the performance because of the overload issue?
Yeah, so the performance is not really something that's worth worrying about. So essentially the C# compiler is highly optimized at compiling strings into code, into DLLs. Normally they come from files, but if you think about the way that Visual Studio works, every time you type a character in Visual Studio, the compiler is running and analyzing your code. And if you have one letter missing from a method name, you'll get a little red squiggle in Visual Studio. That's from a compilation. The compiler happens really quickly. So the speed is not so much a worry there, but what you get by sticking to strings is you get very robust results because the compiler is highly, it's used millions of times a day to compile strings into DLLs. It's not used much to compile arbitrary data structures into code, into DLLs. So it's really just getting that robustness.
Я понимаю, что генератор эффективно работает со строками.
Okay, yeah, I agree on the performance question, but from the client side, when the developer is creating his or her source generator, it will concatenate the strings and manipulate with the strings. So I think this can lead to performance issues.
Yeah, it certainly could. I mean, so the way that I generally write them and the way that I've seen them written everywhere is I create a string builder and then call a method to do the generation and sort of break it down as much as you can into small chunks. And so but each chunk just adds to this string builder. So what you get is you're only ever producing one string at the end, and string builder is highly efficient, especially in .NET Core. So when you're doing your build on your CI server, if you can get that happening in .NET Core, then you get even better performance. But also by breaking down the methods into small chunks, dealing with the strings sort of never becomes a problem. You essentially have one method that generates the method declaration and the opening brace, and then you have another method that generates the first bit of the implementation and then the next bit of the implementation. But because each one is really targeted, it means that you're never having to sort of create this huge string that you've got to escape lots of quotes and manage, and it's annoying. And of course, it also means that if you've got really targeted methods, they're really easy to unit test. So you can unit test your source generator very easily by, call this method, give it what it needs, and it should generate, these two if statements. And that's all that method does. So that's a really simple test, and you end up with a really robust generated output.
Спасибо за твой ответ на этот вопрос.
Thanks, David, for the answer. And one more question. So, do we not need reflection anymore? Can we forget about it?
That's an interesting question. I think we still need it. There are times when we need it. Particularly, well, the most obvious one is source generators only work if what you're doing is known at compile time. And there's lots of scenarios where that's not true. There's plugins and extensions and downloading DLLs from repositories and things and NuGet packages, and none of those things will work with source generators because, of course, at runtime, that's when we load that DLL. We have to look at it with reflection. We don't have a choice. But it is interesting that some of the work that reflection does can be moved to compile time. And the extra sort of layer of interesting bit that comes on here is not just performance, but in .NET 5 and particularly in .NET 6 and going forward, there's a lot of work being done into the linker in .NET, and in particular into various trimming algorithms to remove code that you don't need and to remove DLLs that you never call. And if you use reflection, the linker cannot know essentially what you're going to do. You could do anything with reflection. So the more reflection you can move into source generators, it could potentially make your DLLs more linkable or more linker friendly. So I definitely think there could be a little bit of a trend in future, but it does remain to be seen how much uptake source generators get. They are complicated, and I don't expect that most development teams will be writing them, but I wouldn't be surprised if most development teams end up consuming one or two to help them in some way.
Звучит здорово. Скажи,
Wow, sounds nice, sounds interesting. Do you know, in Microsoft, inside the teams that run the .NET, develop the .NET platform, are there any plans for the usage of source generators where previously you used reflections or something else? Thanks.
I don't know that there's plans, but there's certainly investigations being done into a few different areas. Things like resource files, they generate code. And in particular with resource files, that generator is very tricky because it has to embed types that you provide as a user. And so that's really tricky because you're providing them to Visual Studio, which is a .NET Framework application. So if you're .NET Core, that gets difficult. So moving that into the compiler could be a big win. There's lots of generation scenarios around Microsoft. I mentioned Razor files and ASPX pages. Those sort of things maybe. One that I think is very interesting to watch will be things from the ASP.NET side of things. So there's a lot of work in the routing engine that to try to make, was work done recently in .NET Core to make it super fast with its new endpoint routing, but it still has to examine your controllers with reflection. So if they can get that into a source generator, that might be a really good way to them to generate that endpoint graph, but at compile time. So I think there's a lot of teams investigating, but I'm not sure about plans at this stage. But don't forget, until November, source generators aren't even actually released yet, so it's still a bit early.